Well, I am here with Ben Johnson, and Ben, I have something to show you that I did not warn you about.
Oh man.
Do you recognize any
Oh,
of this? Do you
yeah,
recognize
I do.
these
It looks better in
headers?
color, though. I gotta say.
It does look better in color. I printed out, so in part of my studying for this course, of course, the first place I went was the Fly blog to print out all of your articles over there, and they
Nice.
are super good. So thank you so
Thank
much
you.
for writing all of those. And it has that same that's I don't know if it's you or Fly, but it has that same kind of like irreverent, casual, fun, like conversational tone that I really like. So good job on all those.
Well, thank you. Yeah, I appreciate that.
Hey, I hope you're enjoying this. Just as a reminder, you can learn more about SQLite at highperformancesqlite.com. I'll get out of your way. Back to the interview. So tell me, by way of introduction, where you're working. I just spoiled it, but where you're working, what you do, and how you ended up there.
Yeah. So I'm at Fly.io right now. We do application hosting and server host. Yeah, we put applications everywhere. Kind of as our gig. And I ended up there a couple of years ago. I did a project called Litestream, which is essentially trying to make like SQLite. Make it work on basically a single node, so you can have like automatic backups, and like for a lot of applications it's probably good enough. I mean, unless you need some crazy like HA high availability thing going on, then otherwise, I mean, like a simple SQLite can go a long way. And then before that, yeah, did a lot of consulting work in Go. I've done a lot of work on databases. I did a database called BoltDB. That's in like the
I
Go
did
world.
not know that was you.
Yeah, I did that maybe 10 years ago. I was actually at Shopify at the time.
Okay.
Yeah, we were using LMDB at the time for like an analytics database. I had actually written an analytics database before that. And that's why I kind of ended up at Shopify. We started doing analytics, and we kind of wrote our own database there. And LMDB worked great, which is like another key value store. But we had some issue, and we could not ever track it down. But like every couple of months, we'd have like one server that would just fill up the disk, and we had no idea why. And at the time, I kind of been playing with like doing a port of LMDB to Go, but more just like an educational thing. And then, it eventually got to the place where it was like we couldn't figure out this bug, and we had spent forever on it. And we're like, hey, why don't we just try this this little project you had done on the side, which was Bolt at the time. So yeah, I did that. Before that, I'd done a lot of work on like data visualization. I was actually an Adobe Flex developer, if anybody is old enough to remember what the hell that is.
I feel like I've been around for a while, but I don't know what Flex is.
Yeah, it's basically if you took like React, but like 15 years ago, and it was on the Flash platform, essentially.
Oh,
so
okay.
It was back when like before HTML and like browsers could
Yeah.
really do a whole lot. So it was actually kind of cool, but yeah. Adobe kind of tanked with that kind of stuff. in
Flash, I remember. I was an ActionScript developer, but I didn't
nice.
ever know Flex. So
Yeah.
most people would say you should never write your own database, and here you are having written at least two that we know of, and then some sort of virtual file system for other databases and a little sidecar, and so you're just like you're doing all the things that you're not supposed to do, and you're doing them very well. It seems like.
I mean, I think the first ones weren't very good. That's kind of that's the trick, is like make
Yeah.
sure you get the bad ones out first, and then no, I mean, like I think that it's kind of one of those things where like it's like rolling your own crypto. Like you shouldn't do that, but obviously there was somebody that rolled their own crypto first, and I think you just like kind of if you find some little niche and you just dig into it really deep and just keep going, you can just find fascinating little areas to dive into. So I think I had a little scratch I wanted to itch. I worked at a company that did like behavioral analytics, and I thought they could do it much better. I was actually the data visualization guy at the time at that place, not the database guy. And this is back in like Hadoop, like when Hadoop first came out. And I was like, hey, we should use Hadoop for this thing. It'd be great, because we were spending forever like trying to actually run these reports. And then I started just playing around with trying to make it faster and faster, and eventually I just wrote my own database. I think that's kind of where everyone ends up, right?
Yeah, that is the end state for trying
Yeah.
to make things faster, for sure.
Yeah.
So I want to talk to you about Litestream first. So we have two Lite products, Litestream and LiteFS, and we can go super technical, so don't be shy. So I want to hear about Litestream and how you kind of, I guess, came up with the idea and why you wrote this, and then we can talk about kind of how it works technically.
Yeah, sure. So I think the basis for it was kind of the work I did with Bolt way back in the day. I realized like when you have a database right next to the application, it's really fast. Like, especially when you're used to using Postgres or, I mean, not that there's anything wrong with client-server databases. They're great. But there's just something about not having any overhead, like network overhead, that's just like kind of blows your mind. And it's really simple too. Like there's no external dependencies. You bundle it all up and it's right there. So I think for me, it was more, I was trying to make like application development with Bolt try to work. And it was just, there's a lot of nice things you get with like a SQL database, like schemas and like foreign keys and all that, little things that you don't want to have to build yourself.
Like schemas,
indexes, yeah. So eventually I was like, this is way too hard probably for anyone that's not a database developer. And I tried to look around for other SQL databases that were embedded, and really it's just SQLite out there. That's like the big one. Works on almost every language, and yeah, it's fantastic. So I started developing with that, and I kind of got this itch of like, what is, like for most applications, I think most developers write, like if you want to deploy it out, it needs to have, pretty good uptime, maybe like 3 nines or something. But like you don't need like 5 nines. You don't need like crazy anything. You just want something that's simple, it's easy to run, it's cheap. And the biggest thing I had an issue with was like the disaster recovery piece of SQLite, where you could do like a daily backup or even like an hourly backup, which honestly actually works great for a lot of people. We even have documentation on Litestream about alternatives, and one of those is just back it up every hour, and that's fine. But if you want to actually like track your changes so that you only have kind of this really small window of data loss in the event of like catastrophic events, then something like Litestream where you can continuously back up, like incrementally back up each little set of transactions every few seconds. You really you minimize your actual risk of data loss, and that's kind of the end goal. So yeah, I want to make application development super simple. It runs as a separate process, so you don't have to your application doesn't have to know about it in particular. That was kind of a big design goal as well. Anyway, yeah, I'm just kind of rambling now, but that's kind of where it came from.
No, this is great, and I think one of the things that was so fascinating to me about kind of the structure of it or the architecture of it, and forgive me if this is naive and or wrong, it seems like you the final product is you looked at SQLite and were like, how do I do this without basically touching SQLite internals, right? Because they're very like, we're source available, but we don't take PRs. We don't take anything. It's us 3 guys that have been doing it since the early 2000s. We're going to keep doing it. And so that kind of puts an interesting constraint on, I want to do something with SQLite, but I can't really get inside it. And so I think the approach you took was kind of trick it to be this long running, it works, it keeps a transaction open and it hijacks the checkpoints or something like that. And that to me is oh, that's incredibly, that's very clever, because then people still get to use vanilla out of the box SQLite and then put your thing beside it. So can you tell me a little bit about the architecture and the structure of it and how that trickiness works? And I say trickiness in a good way, because I think it's fascinating.
It's all hacks out there. Honestly, we're moving electrons around. I feel like everything's a hack, honestly. So yeah, I mean, the way that it works is there's basically 2 journaling modes. So a journaling mode in a database, I don't know if you've covered this before, but essentially it's how you safely write changes to a database so that they all get written and they're durable, and that if it needs to roll back, everything can roll back. So one is a journal mode, where essentially you are copying out the previous version of the changes, the rows, into a separate file called the journal file, and then you'll make changes to the actual database, and then you write the changes, you basically delete the journal file after you're done. So at any point you can recover back, if you need to roll back. So that's the journal mode, and that's the old mode of SQLite. It has a lot of drawbacks. It's not very fast. You don't have like concurrency and all that. And kind of the better mode generally, I mean, there's a couple trade-offs, but by and large, like the wall mode, which is write ahead log, that's kind of like the best mode to really run SQLite in. You get a lot of concurrency. You can have a bunch of different readers at the same time, one writer, but they can all kind of intermix at the same time. So the way that the wall mode works, WAL, is that every transaction you make, you'll make changes to pages. So pages are kind of like blocks in your database. And every time you make a change to a page, it'll kind of tack it onto the end of this file called the write ahead log. And then it can reference those changes.
Can I pause you right there?
Oh, yeah, please do, yeah.
So, correct me if I'm wrong, but for the edification of the listener, the two the journal modes are rollback and write ahead. And write ahead we call WAL because it's write ahead logging, WAL. So we've got rollback and write ahead. Rollback is traditional and still default because SQLite is super on about backwards compatibility. They just love it so much, which is great.
Yeah.
Love it. So we've got these two modes, rollback and WAL. WAL is the better one for better, higher concurrency. You can have a bunch of readers, still one writer, which is fine, but you can have a bunch of readers working. Rollback mode writes to the actual database file, and if you want to roll back, it grabs the thing that it set aside, and it puts it back in if you need to roll back. Write ahead, instead of writing to the actual database file, it creates this new file that's like a -WAL, and it writes there and leaves the database untouched until such a time where it takes the second file and basically merges it back into the first file, and then we start all over again. Is that fair so far?
Yeah. Yep. That's great.
Okay.
Yeah.
Perfect.
And then whenever it merges those changes back in, that's called checkpointing.
Perfect.
And the great thing about the wall is that you have every version of a page until you checkpoint it back in. So you can have different readers kind of have a different snapshot of the database at every point in time when they started. So it has that nice property. It's called serializability. So yeah, that's essentially how the wall works. And the issue whenever you have like a kind of disaster recovery kind of streaming backup system like Litestream is that you essentially need to track the changes from the last time you sent an incremental backup. And like the checkpoint is where you kind of have a potential to lose that, where like the database could write some changes and then it checkpoints and clears the whole write ahead log. And then you never caught that last little transaction at the end before it did that.
And so at that point, your database has changed, but you don't necessarily know how. And so you can't send off that increment to some other place to store. It's now become an amorphous blob again that is the database, and now your write ahead log is empty. Is that right?
Yeah, exactly. And you can't detect that necessarily. So you actually just, even worse than like missing the transaction is like you actually corrupting your database potentially. So that's bad. You don't want that.
That is bad.
Yeah. So the one nice trick, this is the little hack, is that SQLite doesn't allow you to actually checkpoint if there's any open readers on the database because they might potentially have changes they're tracking within the wall. So what Litestream does is essentially it keeps a long-running read open on the database, and then whenever it decides it's big enough to actually do the checkpointing, it'll kind of control that process of checkpointing, make sure it has all the data before the process happens, and then it just immediately clicks back in and grabs that read transaction again. So there's it's very
awesome. I love this so much because this is such a clever solution working from the outside in. Like you didn't have to talk to anybody at SQLite. You didn't have to make any pull requests. It's amazing. Tell me on a technical level how. So when you who decides in a Litestream setup, who decides that a checkpoint is ready? Because I know in a traditional setup, SQLite decides, well, it's gotten big enough, checkpoint ready, let's write it. And a certain commit could take a little bit longer because it's doing the checkpointing as a part of that commit. In a Litestream setup, who decides, all right, it's time to commit, and then are you literally plucking it out of the wall file before you allow SQLite to commit, or how do you handle that process there?
Sure, yeah. So what we ended up doing is, we essentially copied the same settings as what SQLite defaults to. I think it's 4 megabytes for a wall. Like once it exceeds that, then it'll attempt to start copying stuff back over. We essentially use the same settings, and then we don't implement the actual checkpointing process. We actually call into the functions inside of SQLite to do the checkpointing. So that's not implemented by us. They do document their whole wall format, so it's pretty easy to read. It's basically the page data, and then it has some checksums and like an incremental checksum and some salt and all those things as well. So there's a lot of like little checks within there just to make sure that you're not like getting the wrong data or getting whatnot. So so it essentially handles it on its own and just copies the settings.
Okay. And so when you reach that point, let's say it's 4 megabytes, when you reach that point, you have being Litestream, you have decided, all right, it's time to transfer this into the full-on .SQLite file. So then you presumably have some sort of internal state that says the last whatever checksum or the last page that you have sent off to S3 or S3 compatible. And so then you investigate the wall file yourself, find where that is, send anything after that, and then let SQLite do the rest and put it back into the .SQLite file?
Yeah, pretty much. And we actually have one little difference is that we actually have it's called like a shadow wall. So essentially we're copying stuff out to like a directory next to the database. And it'll store kind of the incremental things to send off, because you might not have connection to S3 or wherever you're sending to for some period of time. So it doesn't prevent you from checkpointing without sending off.
Oh, that's interesting. Okay, yeah. Say that again. So you have a shadow wall that when you let SQLite commit, in case you can't reach S3, you have put it aside such that when S3 is reachable again, that'll be sent off?
Yes. Yep.
Oh,
and you can track stats of this stuff within, like, it has like Prometheus metrics you can attach, Grafana or whatnot too.
Super clever, because you want to stay. Man, I'm just learning so much. That's why I keep repeating it back to you to make sure I have it. So you want to stay. You need to be safe because you got to stay out of the way of the database. And one place that could fall down is you're trying to send off changes and East 1 is down again. You can't reach it. And now everybody is trying to use this database that you are blocking because S3 is down. And so to get around that, you've got a shadow wall that you can just stash.
Yeah, exactly.
Huh. Did you bake that in from the beginning, or did you have
it was pretty early on. I mean, part of it is that you kind of need to know the previous page that you read, just to make sure that it lines up, because every page that's written essentially has this rolling checksum that goes through the whole write-ahead log, and then the event that your Litestream dies for whatever reason and comes back, it needs to be able to check to make sure that there's not new transactions written or that it hasn't been a checkpoint, things like that. So it does a bunch of those checks, but it has to have the previous data in that shadow wall to actually check it against. Okay,
that makes a ton of sense.
Yeah.
Okay,
and then it just kind of worked out that it happened to be a shadow wall and it's disconnected from S3.
That makes a lot of sense. So then
you really don't want downtime like from your disaster recovery solution. That sucks.
No, you don't want. Then you are the disaster.
Exactly.
That's the opposite of what we're looking for. Okay, so you send incremental backups off to S3 or S3 compatible, right? Which would include at this point Backblaze R2, Cloudflare, something.
Yeah, we also do GCS. Google Cloud Storage. We also do Azure. I should know the other ones, but they're a lot of them are S3 compatible. So
okay, so then in S3, what would you find? Would you find a bunch of little files that are all like checkpoints, or what do you find in S3?
Sure, yeah. So it has essentially two subdirectories. You have one that is going to be your snapshots. So you can configure Litestream to snapshot by default, I think it's once a day. And then it'll, next to that, it'll have like a set of wall files. And those wall files will essentially just keep incrementing up, and they can get replayed in order.
Cool.
And then you basically can reproduce. It's nice because you can actually reproduce the state of your database at any point in time between the snapshot and now. So if you did do this like, delete table kind of business and you need to get back to like 5 minutes ago, you can do that.
Man, that rules. Okay. Yep, that makes a ton of sense. Okay, and then what is the recovery story or like the restore story for Litestream, and how far do you go to aid the developer to do that recovery?
Sure, it's just a restore command within Litestream. So you say Litestream space restore, and then you give it the name of the database, kind of, or the replica where it's going up to. It'll pull it down, and then it'll essentially start with a snapshot, and then just pull down a bunch of those little incremental changes and keep replaying those. And actually uses SQLite to actually replay them. That can actually take a little bit of time if you have like thousands of them.
Yeah.
So it can be beneficial if you actually snapshot more often if you have a lot of changes. So maybe once an hour, depending on your database size. But the nice thing about go ahead.
No, please.
The nice thing about like B-tree databases, which is what SQLite is, and BoltDB, is that like just by default they tend to have a bunch of space in them. You tend to like split trees a bunch, so you end up you never have like a really tightly packed database. And that, plus it's like all text data typically, is that you can actually just compress the crap out of it. So it's like, you might have your database is like 16% of the size of the actual real thing. It's crazy. So it's not. We do, I think, LZ4 compression. So we'll do that and then send it up.
How do you make how do you trick SQLite into replaying these incremental walls? Do you just like, I'm gonna guess and then you tell me why I'm wrong? Yeah. So you pull down a snapshot, which is like a .SQLite whatever. Then you pull down a wall file and then open and close some sort of connection, and SQLite says, "Oh, there's a wall. I'm gonna commit it." Is that it?
There you go. Bingo. Yeah. I mean, we'll pull down the wall files in parallel behind the scenes, and then basically do a bunch of open and closes.
Control what shows up, what's visible to SQLite with naming conventions and stuff.
Yeah, and we can actually improve the open time or like the restore time if we actually did it ourselves. It's not that complicated to replay the wall, honestly. So I might do that in the future, but yeah, it's not too bad.
But there's something so if I were you, I would feel such great relief to know that that's not your job. Yeah. Your job is just to like put the stuff where it goes, and then let the 25-year history of SQLite handle doing the right thing, which feels kind of like, I don't have to worry about that. That's a whole set of problems you don't have to develop for, test for, future proof. That just feels kind of nice.
Yeah, I mean, there's definitely that benefit as well. Yeah, we got into a lot more of the nitty gritty details of SQLite behavior when we did like LightFS next, and we can talk about that as well. But so yeah, that part's not too scary at this point. We actually had to do replays of walls and things like that. But yeah, no, I agree with you. It's nice, just it's not my problem kind of thing.
It's not your problem. I love not having problems. Okay, so let's talk, unless there's anything else about Litestream. I feel like the level of complexity, you were like, that was too easy. Let's double up and write something else. So unless you have anything else on Litestream, I want to talk about LightFS.
Sure, yeah. Sounds
okay.
Good.
So my understanding of LightFS is another, it's like, this is so great. I feel like I love your style. It's another approach of making SQLite do something without telling SQLite that it's doing anything. So my take on LightFS is SQLite has this layer that like integrates or talks to the operating system. Is it like VFS? Is that the layer they call it?
So you can do a VFS within SQLite, which is called a virtual file system, and it has its own API within SQLite. But the problem with that is you actually have to, like, SQLite has to know about your underlying system. You have to load it in manually and all this stuff. Okay. And we really wanted to make it very invisible. So we actually use Fuse, which is like a file. Oh God, I should know the name of what this stands for. It's a user level file system within Linux, basically. Okay.
And so I thought where this was going was, instead of using the Windows or the Linux or the OS X like VFS, it uses Litestream or LightFS. That's wrong. So tell me how how LightFS works, because clearly I had the wrong idea on this.
Sure, yeah. I mean, and this actually stemmed out of Litestream. So Litestream, one of the versions, two of the requests we got more than probably anything else was that people wanted to be able to have something to roll over to, like switch basically the primary node, like have a failover when they do deployments, because you can get downtime otherwise. And there's things you can control with that, or like get around with that. So people wanted to fix, the downtime when you switch over, and they also want to read replicas. So you might have like your main server in Virginia, but you might, it's 100 milliseconds to Europe or 250 milliseconds over to Asia. So like you might want to put read replicas over there and make them super fast for everyone in the world. And I originally tried to do that in Litestream, and I kind of got something working, but there's just like, since you don't have control over SQLite and like the actual the write calls and the reads and everything, you don't have quite enough control to really guarantee that you're not going to get corruption or that you're not going to send wrong files or whatnot. It's a really touchy thing when you get down to that level. So the idea was basically to kind of take over some control over that. So we made this essentially pass-through file system called LightFS. And what it does is when SQLite does a write to the file system, it'll go through our file system so we can detect it, and we basically pass it off again to the real file system. So we can track every single write call that goes through, and that gives us also, we can track the locks on the actual database too, because it's like a bunch of locks that they use. So we can detect when a write starts, when it ends, and all kinds of things. Just a lot of it's from the locks themselves. So we essentially can demarcate the start and end of all transactions, and then we can track all the writes that occur in between them, and then we can kind of read out those changes for each write, and then stuff them into what we call an LTX, LightFS transaction file. And that's essentially like a little package of like a change set for a transaction that we can ship off to other replicas. So they can replay that same transaction, and it's, again, just like page changes. So we can have essentially a primary, and that gets all the changes, and then they can ship them off to the other replicas.
So help me understand, and this is my low-level systems knowledge, or rather my lack of low-level systems knowledge showing. How do you sneak in? I'll be honest, I don't know what a fuse is. I know it's all caps, and I know that neither of us know what it stands for. But how do you sneak in between SQLite and the actual file system? What does that even mean?
Sure, yeah. So I did actually remember what it is. It's file system and user space. So you're essentially writing an actual file system. And it has calls for writes and make directory and all that stuff. And they're actually kind of fun to build. Honestly, I built one a long time ago where
says the guy that builds databases for giggles. So take that with a grain of salt, everyone.
No, I made one like a long time ago where it was like I wanted to be able to see my GitHub, like look through GitHub, and like you can like basically look at GitHub as a directory tree, so you can like look at repos and users and like
it's pretty cool. Yeah,
just a little throwaway kind of fun little project.
You got me. That's pretty cool.
Yeah. I think I was like mentoring some students one time on like some stuff, and we're like, let's make a project, and it's just what we came up with. So
yep,
it was a random. Anyway,
those students are going to be just fine if that was their little project. They'll be okay.
So we ended up. File system. So essentially, like load it up as a file system, as you would like another file system. I mean, there's a mount command within Fuse. So essentially, like it's literally a file system. And then you also give it a target for where you want it to write its data, which is on the normal file system that you're already using. So it kind of has its own data directory and whatnot behind the scenes on your file system. It's just it kind of makes a little shim in between the two, essentially.
And then for the user, for the developer, how do they make SQLite aware of LightFS?
Sure. So they just have to point it at the directory that comes up from that file system, and they can start making databases just in the way they normally write them. Like you just open a connection, write your database. All the changes happen invisibly, and they get kind of shuttled off behind the scenes. So it looks exactly like a regular SQLite database. Just on a different file system.
Man, that is super clever. Okay, so you have LightFS is a custom file system that is basically like a decorator or a proxy or something, and so you're listening you're not listening. SQLite is actually writing to you, and then you're passing that through and setting it aside. And then when you reach a certain point, maybe the transaction closed or you've gathered a few transactions, I don't know. When you reach a certain point, you fire this custom packet off somewhere, and LightFS is waiting on the other side to receive this unified this file format that you both speak, and then you turn that back into SQLite on the other side and pass it through to the underlying file system over there?
Yeah, essentially it's, more or less. So we package up every transaction separately, and then it stores on the primary node for some period of time, and then the other nodes actually connect up to the primary, and they'll just continuously stream down anything that comes in. So
I see.
From the time you actually write the transaction, it takes less than a millisecond to actually replicate, plus any latency, like physical latency.
Plus the speed of light. Okay.
Yeah, that dang speed of light. Yeah.
I know. We'll get it one day. So you have these replicas. These other servers have LightFS on it, and the other servers are aware of where the primary is, or rather, I guess, what the primary is, and it has some process there that is constantly polling, or there's something fancier to watch for new transactions it needs to pull. Is that right?
Yeah, it's just a constant connection. That's
okay.
Yeah.
Okay.
Streams them down, and then it has a bunch of checksumming and all that stuff in there to make sure it's everything ends up in the appropriate state. We actually do like a rolling checksum, which I'm sure other databases have done this. I don't think we're novel by any means, but like it's interesting that we'll take the pages that are changed, and we'll essentially do an XOR checksum to remove the old version of the page from the checksum, and then put in the new version of the page as a checksum. So it can actually compute like a rolling, like an actual checksum for every single transaction in the database. So we actually can really clearly see if we have any corruption anywhere in the process, which has been nice. And we can actually, there's some.
Yeah.
Oh, go ahead. Yeah.
No, I was going to say that seems like rule number one is you've got to make sure that everything that's supposed to get there gets there, and nothing that's not supposed to be there gets there. Because if you end up with, a corrupted replica down in Australia, you're hosed. That was what you were trying to solve here.
Yeah. And people also wanted the failover piece where you could have multiple primaries. You can have multiple candidates essentially. So you might have two that are in one region, and they can just flip-flop when you do a deployment. We actually use console, like HashiCorp's console is one of the things you use for that. So it's optional. You can either have like a fixed primary, which one machine is always a primary, or you can actually have it where it does a leader election and it can flip-flop over. But so we have some looser guarantees when you use something like console about who can actually, like when a transaction is actually persisted, it needs to actually get to the other candidate. But you can have a scenario where you get a write that's actually written down and not replicated to the candidate yet. So when it does flip, you could lose that little sliver of time. We need to be able to check to make sure that the checksums, if they do change between different nodes, that we can re-snapshot and send those down to the replicas.
Okay. So talk to me about how do you do. So you've got you got a primary in Dallas and a replica in Australia. Somebody in Australia does a write. How do you do write forwarding inside of fly.io? Because I understand this is kind of y'all's bread and butters. Put stuff on the edge and we'll figure out the rest. And then is it possible outside of fly.io?
Sure, yeah. So LightFS isn't specific to Fly. We certainly want people to use it on there, but it's open source. It's all Apache 2, so you can go do whatever you like with it, and it'll work on any system really. There is some stuff we do in there. So one issue we ran into after we got stuff working was that we originally had probably the best way to do it is to have the application send the writes, send all writes to the primary, and then you can read all your reads from the replica. But again, that speed of light thing where you might send a write to the primary, but then you read from the replica before the write actually gets down to the replica. So you can get this out of order kind of appearance in the application. And we spent quite a while trying to figure out the best way to manage that. And essentially, like, we don't want everyone to have to like check for like a transaction ID on every single read they do and do a bunch of, playing around to make sure they have like a consistent view of the data. So we actually have an optional like HTTP proxy you can run in front of your application. So it'll actually check for the essentially the right transaction when it went in, and make sure that your reads are caught up before the next read transaction comes in, and it does that kind of invisibly to the application itself. Smart. So we kind of like sandwich like your application's here, and there's like a proxy here and like a file system here, like lovingly hugging your application.
Yeah.
To give it consistency and all that. So so right now it's mainly on the application side we typically recommend. We did some work with write forwarding within SQLite, but it was more of a pain than I would say it's worth typically.
Yeah, that sounds pretty complicated. So what's the story on, like, if somebody did want to spin up LightFS, what is the like how do you get it? How easy is it? It sounds like you've got it pretty nailed, but tell me, what would one do?
Yeah, we have some docs on Fly. You can check out as well. I think it's fly.io/docs/LightFS. You can go on there and essentially we have it all bundled up as a Docker container or Docker image. The funny thing is we actually don't use Docker as like the thing, because you actually need to pull the binary in to your own Docker image. So we just actually copy it out, it's like a really convenient way to use Docker to like copy binaries if you're using Go, because it's all static binaries. And yeah, so you can copy it down to your development or your Docker image, and you run it, and then it kind of runs your application as a supervisor. And then beyond that, if you have an application where your writes all go through like post and patch and all those kind of standard HTTP verbs, and then your reads all go through gets, then it kind of just works more or less. You essentially just point your application. You can actually do it with like WordPress. I think we've done that before. We just spin up WordPress and like point it at LightFS, and it just magically does the right things, which is kind of cool.
I bet that felt pretty cool.
Yeah, that was a good one.
If you can do it, if you can just make it work with WordPress, that's how you know you've got it. You've got it sorted.
Oh, yeah.
That's pretty amazing. So, what do you see for the like philosophical demarcation between Litestream and LightFS, and where do you want to take both of them moving forward? Because is this what you do at Fly? Is this your full time? You just write SQLite stuff and talk about SQLite and build Litestream and LightFS? Is that all you do?
No, it's not all. It's not the only thing I do. I do that, but I also we do a bunch of like back end work, reliability stuff. We do a lot of.
You do that?
Yeah.
Oh, okay.
So just kind of.
I thought you got to just play in the lab all day.
Sometimes, yeah. Sometimes you do. Yeah, I mean, sorry, what was the question?
The philosophical demarcation between the two things, and then what your vision for the future of them is.
Sure. So Litestream I kind of realized like adding all the replication stuff and all that just made a lot of pieces a lot more complicated, or a lot more complex. And essentially, Litestream is kind of a disaster recovery only solution. Like that's all it does. So if you have a single node and you want to do a streaming backup somewhere to S3, it's great for that. Like you can do that all day long. And then Litestream is never going to be more than that. That's kind of its goal. And then LightFS is kind of the distributed systems. Like you need replicas, or you want replicas. You need low latency and all that stuff around the world, or you want failovers, all kinds of stuff like that. It has a lot more complexity. We also have a thing called LightFS Cloud, where you can stream your backups up to Fly, and we'll save them, give you like point in time recovery as well.
So. Would it be reasonable to say that you could use LightFS to get embedded replicas everywhere, and also use Litestream to stash all that away on S3?
You can. It gets a little more complicated, but it is possible. You can run it because you might have multiple primaries. That's kind of where the issue comes in, and you essentially have to replicate each separate primary.
Okay.
So it's not as much fun doing both. But LightFS Cloud is kind of the disaster recovery side of the LightFS piece. Okay,
that makes sense. And what do you see beyond, or maybe inclusive of, building out LightFS Cloud? What do you see for the future of LightFS?
Sure. I mean, I think we might. I mean, LightFS Cloud, it's a paid service, $5 a month. You can get backups up there. And I think, we have some work we want to do around moving some of that stuff into like a simpler version into LightFS itself. Mm-hmm. So you can do streaming backups to S3. It gets a little more complicated when you don't have like a single service that can kind of manage like leadership and things like that. So there's some little hairy problems to get in there. But I would say as far as LightFS, I mean, a lot of it is, I think improving performance is always a good thing, optimizing and just squashing bugs. But, I don't have I wouldn't say I have like grand features. I mean, we have some things that people have requested, like having an HTTP query API. So you can actually query LightFS over HTTP, which I know Terso. Actually, I think we talked to Terso actually to see what their format was for that to try to use the same one. Mm-hmm. So it's, there's been a handful of requests like that.
Yeah, that's super interesting.
Yeah, but I'd like to keep it mostly simple, though. I mean, I think a lot of database companies just tack on features all the time. I used to be an Oracle DBA like 20 years ago.
Oh, yeah.
And
you come by it honestly. I see.
Yeah,
okay.
The number of books that you have to read just to understand the basics of Oracle is crazy.
These are just MySQL right here.
Yeah.
I mean, they just keep going. You got to know a lot to run these things. Okay, I like that. It feels to me like this is like Litestream and LiteFS are spiritual cousins of SQLite in that way, that it's like small, fast, reliable, and kind of done. Like there's, SQLite will continue to add things as we invent, CTEs and window functions and all that stuff. They continue to push forward. But in terms of hey, LightFS is good at what it does. We'll make it faster, we'll make it more reliable, but we're not going to just continue to bolt nonsense on there. It feels like, it has a home with SQLite. Y'all are twins.
Yeah, I really love projects that have a scope, and like Bolt was kind of like that. At one point, I marked it as 1.0, and I was like, this is done. And, I mean, obviously, bugs can come up and whatnot. But essentially, I wasn't adding any more features. It's a key value story. You get keys and values. There's not a lot more than that.
Yeah, it's pretty straightforward. Yeah.
So yeah, that's kind of where that. I like projects that are like that. I feel like there's too many projects that just go way too deep and add too many things. And I feel like whenever people talk about their favorite projects, it's never like, oh, I love this grandiose, complex thing, or oh, I like rsync, or some simple tool does one job, it does it great.
Yeah.
So.
The same with their favorite little Mac apps or whatever. It's this random little thing you've never heard that solves this one problem perfectly, and everybody's in love with it.
Oh yeah. MonoDraw. Have you ever used MonoDraw?
No. What is that?
It's like an ASCII art editor, so you can draw diagrams in ASCII art. It's it's a good product, and honestly, but they're not adding crazy features. There's no sharing to Twitter, I don't think, or whatever. Every product seems to add. It's great though.
There's no AI in there.
And not yet.
Not yet.
Yeah. No, God forbid.
Yeah. Okay. I kind of want to finish by talking about this SQLite renaissance and what is your, which I think you have helped drive with these tools. So what is your perspective on why now? It's been around since the year 2000, but why now? What is driving it, and where do you think its best and highest use case is?
Sure, yeah. I think the Renaissance is driven by a couple things. I would say complexity is a big thing, where it just seems like there's so many dependencies you need to add to a project just to do a hello world at this point, and it's a little absurd for certain things. I mean, not for everything. I mean, everything has its place, obviously.
Sure.
There are tools that are written for a reason, but you don't need to do some Google scale project when you just need it to do it. So I think complexity is a big piece. Just having one file.
And by that you mean the rage against current complexity, and you feel like this is part of swinging it back?
Yeah, for sure.
Okay.
Especially for certain projects where you don't need all that stuff. When you have SQLite, you don't really need a cache like Redis or something, or Memcache. Everything's right there, right next to you in memory half the time, and adding a cache would be ridiculous most of the time. So I think that there's a lot of pushback around that. I mean, also other tools people use Elasticsearch, but you may not need that based on the full text search that's built into SQLite. Or like you have JSON support within SQLite. And like there's all kinds of little great tools within there that do a lot of the job. It's kind of like I write in Go mostly. And like the Go standard library has like 90% of what I need for like most applications, surprisingly.
I've never used Go, but that is the thing that I keep seeing on Twitter. It's like, oh yeah, Go has that. Oh yeah, Go has that. It's like, that seems cool.
That's great. So I think there's a lot. I think there's a lot you can do with just a basic SQLite app, which is great. And I think the other thing too is just the speed of our machines is just wild at this point. Where like you can really, you can serve. Again, I write Go, but like Go and SQLite, I can serve hundreds or thousands of requests per second with a fairly minimal setup, which is wild. And most people are getting maybe less than one request per second on their app. Like you don't need some crazy deployment, or at least not to start. You can always. What's that?
We are getting less than It's like we get thousands of requests per month, and you're like, oh, okay, you'll be just fine.
Even per day. there's like 86,000 seconds per day. So I think that there's a place, I think, for SQLite for, I would say, the vast majority of applications. And once you start to scale, there's reasons to scale, there's reasons to break things apart, especially when you get to like a bigger organization. But a lot of times you're writing, either like an internal app for somebody or you're starting to start up or those things. And those don't need to be crazy, I don't think.
Yeah.
I'm also a big believer that like whenever, I think it's been said where like every time you scale up like an order of magnitude, you have to rewrite your application. Maybe that's not like quite the exact.
I like it though. We'll go with it. Yeah.
Yeah. It's not the exact.
Sounds good to me. Yeah.
Idea. Maybe every 2 orders of magnitude you got to restart, but I think you eventually have to rewrite anyway. I would say to some degree, and that may be that you move to a different database down the road if you need to, but you don't need to plan for that at the moment.
Yeah, and I think one of the selling points of SQLite is that it's it's very powerful, but it's relatively constrained. And if you need to move on to Postgres or MySQL, you're going to have a pretty easy time doing that. Like you'll have to set up a bunch of stuff, but your actual queries and stuff most likely are going to work, especially if you move towards Postgres. I feel like they took a lot of inspiration from Postgres versus MySQL, whereas going from Postgres to SQLite is going to be a lot harder. That you don't want it to go that way. So it does seem like the graduation story, should you need to get there, is pretty good. It's pretty straightforward.
I think 100%. And there's a lot of cool stuff in Postgres. By all means, like I don't mean to knock any other database. You can use Mongo if you want to. Like there's a place for everything. But the graduation stories. What's the opposite of the ungraduation story? Is it's going to be rough, probably.
Or getting held back, something like that.
There's cool stuff like lateral joins in Postgres. That's cool, but you don't have that in SQLite. Although I would add, like a lot of things you don't actually need when you actually have a database right next to you in memory. Like I feel like a lot of like complex, big, huge queries you could break up into small queries if you don't have any, per query overhead like latency.
Right. If there's no 25 millisecond penalty to get to the database, you're not having to do everything in one shot. Yeah. You
can do like hundreds of queries in a page, and it's not a big deal in SQLite, which is nice.
I think the SQLite docs show how many queries are run on a single page.
It's like 200 queries.
It's like, it's like 220 queries. And then it says, page generated in 0.001 seconds. And you're like, okay, that's kind of cool. I get it. So I like that. Okay, so is there anything else you want to cover about SQLite? I'll tell you what. I've learned so much, and this has been such a blast, and I'm very grateful for your time to educate me. So is there anything else you want to cover about SQLite, LightFS, Litestream, or Fly.io?
No, I think that's great. I think that there's still a lot of potential out there, like the things people can build on SQLite and tooling, and there's always actually one thing I really want to like make, and I kind of like half made it.
Here we go.
I just didn't actually.
This is what I'm talking about. Give it to me.
So I did like a proof of concept of this, and it worked. Okay. I just didn't actually build it out, and it kind of needs to be written in something more low level, like Rust or Zig or C or something like that. Is that I wanted to make basically a driver for SQLite that will run how do I explain this? So like it connects over SSH and then communicates with the SQLite 3 binary on the other side to perform queries. So you actually get, it actually works like as a, this is such a crazy idea. It's essentially like a remote connection for SQLite.
This is client-server SQLite.
It's 100% client-server SQL. So I actually called it, I think it was like SQLite. It was like a mix of like SSH and SQLite. And but the idea is not, I mean, you could use this in something, you know, production. Like if you have like, a lot of times if you have like workers, they might be in separate nodes and might need to connect up to the database. But it was mainly for like, I find the biggest hurdle people have is for like GUIs. Like they need to, like they want to have a GUI for SQLite, and it's hard to do that when you have a remote SQLite database.
It is. Yeah, that is definitely hard. This is insane. And you should absolutely do it. This is a great idea. So
there's potential.
Go tell Kurt, go tell whoever you need to tell that some random person on the internet said you need to do this, and you should devote all your time to this now, because that sounds amazing. This is that kind of like this is that kind of crazy where you're like, yeah, this is crazy. I'm gonna do it. I like it. That sounds awesome. You did a proof of concept. How far did you get?
I got it working. I mean, so it does some stuff. I actually made a request to SQLite to see if they'd make a binary format, because the biggest issue is actually connecting, and then you have to like, you know how it'll say like SQLite and then do like a greater than sign for the prompt, like essentially for the results and like for parsing out errors and stuff like that. I need to like remove all the prompting it does, and it has some like weird prompting rules. So it's actually not that hard.
Yeah,
it was really more just a bunch of weird little things. But it actually does work. It'll actually communicate over and run a query and get the results back, and So anyway,
every now and then there's a guy like this in the Laravel ecosystem, of which I'm a part, where it's like, you're a mad scientist. Like the stuff that you do. You know, this guy, the stuff that he does with PHP, it's like nobody should ever do that, but this is awesome. No. And I feel like you're the SQLite mad scientist. This is crazy, and I love it. I
mean, there's some cool people doing cool work as well. Like Alex Garcia does. He's done a bunch of extensions. I think he did like a vector database within SQLite. Philip O'Toole did RQLite, which is basically SQLite over. We used to work together actually. It's funny because. Cool. We didn't work on SQLite at all at the same time, but we separately just did our own paths. And they're like, oh, hey, we're both doing this stuff. But yeah, he does it as like a distributed system over Raft, and which is a consensus protocol. So yeah, there's a lot of cool stuff out there. And then I know that
somebody
like,
just wrote, there's of course Terso, and then somebody just wrote a like, I don't know if it's wire compatible, but somebody just wrote a Redis clone in SQLite.
Oh, I did see that. That's Redca or something?
Redca, I think.
Yeah, I saw that.
I think that's right.
I think Cloudflare does D1, and it's nice. I like communities that are still pretty small, and I feel like it's still kind of early days, where like everyone's not super competitive. So like some people will borrow ideas from other people, and like I borrowed some stuff from Terso for their HTTP API, and I think their local replicas use some of the stuff from LightFS, and so that's fun.
Yeah, it's fun. I do like the proliferation of like good options in this space. And funny enough, like I feel like one of the drawbacks that everyone is always talking about, is, at least on Hacker News, is like SQLite doesn't have types, and you're like, it's a long story, but if you're using it for a key value store, that suddenly is a great benefit, because you can put anything as the key or the value. And so it's kind of fun to see people like do a Redis re-implementation, because it's like, well, you just throw anything in there and we'll hang on to it for you.
I used to work a lot in like key value stores, and really it's like, it seems like it has lots of types compared to that. So
I guess that's true.
It's kind of fun.
Okay, well, I really appreciate you doing this. Like I said at the beginning, I've read all your work. I'm a big fan, and so this is a delight for me. Where can people keep up with the stuff that you're doing, and I guess where can they follow you?
Sure, I'm on Twitter. I've been as active lately, but I have some other work I'm going to be doing soon, so I'll probably be a bit more active there. The Fly blog is usually a good spot for content as well, or just open an issue on GitHub, or just reach out. I'll say hi.
Okay. Well, thank you so much. This has been wonderful.
Yeah, thanks for having me. Appreciate it.
Yep. See ya.